In this video, we will practice doing combinations of transformations. That means doing two or more transformations in a row. So, we need to do the following two transformations for problem number one. We are going to reflect the preimage, this triangle, over the line y equals 7, followed by y equals -1. And we'll draw the new triangle. Look, this used to be -7, but if I tried to reflect over -7, it was going way off of the graph, like way off the graph. So I've changed this to +7. So if you're working on a worksheet that still says -7, fix it. Okay, so the line y equals -7, the line y equals +7 is a horizontal line at 7. Notice that they are counting by 2's. So 7 is going to be between the lines like this. Okay, so that's going to be the line over which we will do our first reflection. So we will just reflect one point at a time. Okay, this is still going to go off the graph a little. Notice that this point is 2.5 units below this line. So I need to go 2.5 units above the line. So there's my half, there's 1. So I need to go up 1 more. So this will be where this point is. Okay, now notice that this point right here is half a unit above the line. So I'm going to go half a unit below the line and my point will be there. Okay, notice that this point is half a unit below the line, so I'm going to go half a unit above the line. Okay, let me just clean this up so you don't think that's part of it. So these 3 dots will represent the reflection. Okay, so we've done the first transformation, the first reflection. Now we need to do a reflection over the line y equals -1. Okay, fine. The line y equals -1 is going to be a horizontal line at -1. So again, that's going to be between these lines. All right, it's in the middle because they're counting by 2's. Okay, so now let's take our purple triangle and do this reflection. Okay, let's start with this point right here. This point is, let's see. Okay, this point is at 9. Let me just count the squares. This point is 1, 2, 3, 4, 5, 6 and a half squares above the line. Okay, it's 6.5 squares above the line. So I need to go 6.5 squares below the line. So there's my half, and now I'm going to go 1, 2, 3, 4, and I'm going to have to estimate. Okay, that would have been about 5, and this would have been about 6. So boom. Okay, that's my new point. All right, how about this point right here? This point is 1, 2, 3.5 squares above the line. So I'm going to have to go 3.5 squares below the line. Well, there's your half, and then there's 1, 2, 3. So that point's going to be right there. And then what about this point? That point is, let's see, 1, 2, 3, 4.5 squares above the line. So I'm going to have to go 4.5 squares below the line. So there's my half, and there's 1, 2, 3, 4. So that point is going to be right there. So if I connect these, that will be the reflection. And that is what the reflection would look like. Okay, I might have to zoom out just so it will even fit. There, that's a better view. Okay, so that's it for problem number one. Problem number 2 asks, what one transformation is this double reflection the same as? Okay, so in other words, instead of reflecting to the purple triangle and then reflecting to the red triangle, what transformation would take me directly from the blue triangle to the red triangle at once? Hopefully you can see that the blue triangle and the red triangle are turned the same way. They're not backwards. They are not actually reflections of each other. It's just that the red triangle is lower than the blue triangle. So I should be able to get from the blue triangle to the red triangle by doing a translation. If I just took the blue triangle and slid it down, I would get there. So it's just a matter of how far I have to move. Okay, now look at these points to help you see. Okay, look at this point right here and look at this point right here. These are corresponding points. If I move straight down, okay, if I'm counting squares, that would be 1, 2, 3, 4, 5, 6, 7, 8. 8 squares. Okay, now this distance of 8 squares is really 16 units because they're counting by twos. So if I move down 16 units, that should do it. Okay, so translation down 16. That's the transformation that would take us directly from the blue triangle to the red triangle. So what's the rule? The rule would be x comma y becomes. All right, the x values aren't changing. When you move down, that's just affecting the y value. So y minus 16, because there's your down 16. Okay, how do the final triangles in number 7 and number 10 differ? Okay, well, we haven't done number 7 and number 10 yet, so I'm going to have to get back to you on that. In fact, I think this problem refers to another version of this worksheet because number 7 and number 10 don't even involve triangles. So we're just going to have to skip. We're skipping number 4. Okay, moving on. Use the trapezoid in the graph to the right to answer questions 5 through 7. Reflect the pre-image over the x-axis and then the y-axis. Okay, so first we're going to reflect over the x-axis and then the y-axis. So let's do it one point at a time. Okay, consider this point right here. It is 1 unit below the x-axis. Well, okay, it's really 2. It's 1 square below the x-axis. So the image should be 1 square above the x-axis. All right, look at this point right here. That's 1.5 squares below the x-axis. So I'm going to go 1.5 squares above the x-axis. Okay, look at this point right here. It's 3 squares below the x-axis. So I'll have to go 3 squares above the x-axis. And look at this point right here. It is 4 squares below the x-axis, so I must go 4 squares above the x-axis. So I will just connect these dots down. So there's the image after we reflected over the x-axis. Now we're supposed to reflect over the y-axis. So again, let's just take it one point at a time. This point is 1 square to the left, so I will reflect and go 1 square to the right. This point is 2 squares to the left, so I will go 2 squares to the right. This point is 5 squares to the left, so I will go 5 squares to the right. And this point is 4 squares to the left, so I will go 4 squares to the right. All right, so this red trapezoid represents the final answer after both reflections. Okay, so we've done number 5. Number 6 says, now start over, reflect the trapezoid over the y-axis and then the x-axis. Okay, and let's see what happens. Okay. All right, let's do it step by step again. So if I take this point and reflect over the y-axis, that's going to be here. If I reflect this point over the y-axis, it's going to be here. If I reflect this point over the y-axis, let's see, that's 4 to the left. So I go 4 to the right, that's going to be here. And this point is 5 to the left, so 5 squares to the right. And let me draw it. All right, so there I've reflected first over the y-axis, and so now we're supposed to reflect over the x-axis and see what happens. So if I were to reflect this over the x-axis, okay, like this point right here would end up here. This point right here would end up here. Do you see a pattern? This point right here would end up here. And this point right here would end up here. So either way, we end up with the same trapezoid. Okay, so we've done number 6. Are the final trapezoids, and here it says from 14 and 15, but obviously they meant number 5 and 6. Are they different? No, clearly they are the same. Okay, they're the same. So far it looks like the order in which you do the transformations doesn't matter. We did the same 2 transformations, reflection over the x-axis and reflection over the y-axis. Reflection over the x-axis, reflection over the y-axis. All we did was change the order, and we got the same answer. So maybe the order doesn't matter. All right, look at number 8. They want us to specify a sequence of transformations that will map triangle ABCD onto rectangle, did I say triangle? Rectangle ABCD onto rectangle PQRS. So there's more than one correct answer, but here's the first thing that pops into my mind. I'm imagining first doing a rotation that will get this rectangle turned from being horizontal to vertical. And then once it's vertical, then I can do a translation and shift it down onto the other rectangle. So I'm going to do this in 2 transformations. So first, the rotation. I have to think about rotation around what point. So imagine that I'm going to rotate around point B itself. So imagine that this corner were nailed to the table, and I were to turn the rectangle, it would spin around this point, but point B would stay where it is. If I did that 90 degrees, okay, then this side of the rectangle that I just colored in green, if I rotated 90 degrees clockwise, then this green segment would end up here. Okay, so now that's going to become the bottom of the rectangle. All right, similarly, okay, if I also rotated this side of the rectangle with it, and I rotated the whole thing, then that side of the rectangle would become this side. Wait, so this is 4 units, so that would be like this. Okay, so hopefully you can see this green L rotating and becoming the pink L. All right, and that L is really enough to show you where the rectangle is, because it's a rectangle, it's symmetry. So the entire rectangle would become this rectangle. All right, so far I've done a rotation of 90 degrees around point B. Okay, so we need to write this down. So rotate 90 degrees clockwise around, and point B is the point 1, 1. Okay, that's the first transformation. Okay, so that's transformation number 1. And then transformation number 2, this is where we take this rectangle and we just slide it down. Okay, so I'm just sliding it down like from here to here, a translation. So the question is, how far do I need to slide it? Well, just pick a pair of corresponding points. Okay, so for example, point B. How far would I have to move point B to get it to land on point Q? How far is that? Well, let's see. That's 1, 2, 3, 4, 5. So from point B to point Q, that's a motion of 5 units down. So that would be the same for all of these. I'd have to move each of these vertices down 5, and it would land on P, Q, R, and S. So that's going to be my second transformation, is a translation down 5. So those two transformations in sequence would take you from the original horizontal rectangle to the vertical rectangle. It would map the first rectangle onto the second rectangle. Okay? All right, number 9. All right, I'm going to pause the video and think about this for a minute. You should do the same. Pause the video and think about what it would take. Well, to be honest with you, at first I was thinking about doing a 180-degree rotation. Okay, because if I did that, all right, look at this. If I were to rotate this 180 degrees, that would end up right here. So a 180-degree rotation around this point would turn this first image into the second image in one shot. But they said a sequence of transformations. So that makes me think that I'm supposed to do at least 2 transformations. So I'm going to do it the long way just because it seems like they want me to. Okay, so instead, how about if I do a translation? You know, if I do a slide, a translation, followed by a reflection. Let's try that. Okay, what if I just slid this image over to here? All right, if I just moved it over, okay, wouldn't it look like this? All right, so how far would I have to move it? Well, look, if I'm moving CD to this position, I just moved it 1, 2, 3, 4, 5, 6. That's 6 spaces to move CD to here. Okay, don't count the space in between. Don't count the 4 spaces in between. You have to count how far it takes to get from C to C prime. Okay, that is 6 spaces. Okay, so that's transformation number 1, is translation right 6. Now, hopefully you can see that this purple trapezoid is a mirror image of this black trapezoid underneath, with this as the reflection line. Okay? So if I reflected over this line, the purple triangle would fall onto the black triangle. So that is a reflection over the line y equals 1. All right, this is a horizontal line at 1. That's y equals 1. So that's going to be my second transformation. All right, reflection over the line y equals 1. So if I do both of these in sequence, the first trapezoid will will map onto the second trapezoid. Slide it to the right and then reflect it upside down and you've got it. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.